Across critical infrastructure, from manufacturing lines to water systems to high-density data centers, there's one device engineers count on for absolute reliability and precise control: the Programmable Logic Controller. Today, we're breaking down why PLCs are the backbone of modern automation. A Programmable Logic Controller, or PLC, is an industrial-grade computer that's designed specifically for real-time control. PLCs were originally created to replace large relay panels, but they've evolved far beyond that. Modern PLCs are built to run non-stop, execute logic with deterministic timing, and survive harsh environments where normal computers would fail. Their core job is simple: monitor inputs, make decisions, and control outputs reliably, accurately, and 24 hours per day. Inside every PLC, you'll find a few essential components. You have the CPU, which is the decision maker, memory, where your ladder logic or control program lives, a power supply designed for stable industrial-grade operation, and your I/O modules, the connection to the real world. In many modern systems, the PLC will also interface with distributed I/O or edge devices. For example, a WISE controller handling local automation logic, or an ICP-USA DL series environmental data logger feeding real-time temperature and humidity values directly into the PLC. This modular approach creates a far more scalable and reliable control system. So what does all of that look like in the real world? Well, in manufacturing and water systems, PLCs coordinate complex sequences, like opening and closing valves, controlling pump seeds, monitoring tank levels, running interlocks, and synchronizing motors with precise timing. These systems often rely on supporting modules like analog input units, environmental loggers, or small automation controllers, feeding real-time process values into the PLC so it can make informed decisions. And in data centers, PLCs are increasingly becoming part of the core infrastructure. They work alongside environmental sensing modules like the DL series, which track temperature and humidity. They're paired with power quality devices such as the PM3000 series power meters to monitor circuit behavior, load conditions, and energy usage. And they often depend on gateway devices like the TGW Modbus TCP/RTU converters. These are used to bridge a legacy Modbus RTU equipment into modern Ethernet-based PLC networks using Modbus TCP. Together, these devices give the PLC immediate visibility into cooling performance, energy consumption, and environmental conditions, all essential for maintaining uptime. A PLC doesn't work alone. It communicates across an automation network with HMIs, SCADA systems, additional PLCs, distributed I/O modules, environmental loggers like the DL series, power meters like the PM3114, and gateway devices such as the TGW700 series. Protocols like Modbus RTU and Modbus TCP are common because they allow a PLC to interface with almost any industrial device, including older equipment still running over RS-485. In larger facilities, remote I/O plays a major role. Instead of wiring every sensor back to a central cabinet, remote modules like the M7000 or TM series collect sensor data locally and send it back to the PLC. This makes installations cleaner, more cost-effective, and easier to scale. And of course, there's the programming that brings all of this to life. PLCs use ladder logic, C, function block, and structured text, languages designed around real-time control. Unlike a PC, a PLC executes logic in a deterministic scan cycle. Read inputs, execute logic, update outputs, and repeat. That predictability is why so many facilities pair PLCs with reliable edge devices, such as WISE controllers for on-site logic processing, or DL series data loggers that maintain trend history even during network interruptions. All of this contributes to a system that stays stable, repeatable, and easy to maintain. So to summarize, a PLC is the industrial controller that monitors your inputs, executes your logic, and drives your outputs with the reliability that mission-critical operations demand. Whether you're automating a manufacturing line, a water system, or a modern data center, the PLC remains the foundation of automation, supported by tools like environmental loggers, power meters, distributed I/O, and network gateways that extend what the PLC can do. If you want to see how a PLC communicates with SCADA systems and other devices, check out our full breakdown of Modbus. And if you want more deep dives into industrial automation, don't forget to like and subscribe for more. And lastly, if you need any help putting together or designing your next integration project, please don't hesitate to reach out. You can contact us at sales@icp-usa.com, or you can head over to our website where we have 24/7 support at icp-usa.com. Thank you so much for watching this video.